In this one, our domain is the positive integers, and our statement to prove is for all n, 1 plus 4 plus 7 plus adding up to the 3n minus 2 term equals n times 3n minus 1 over 2. Now, you can consider this p of n. Now, one thing I want to make very clear is that p of n is not 1 plus 4 plus 7 plus 3n minus 2. Okay, that's not p of n. P of n is the whole thing. P of n is this whole thing. It's both sides of the equal sign. Remember, think of P of n as a sentence. It's a fragment if you just have the left-hand side or the right-hand side, but not both sides of the equal sign. Okay? P of n is also not just n 3n minus 1 over 2. Right, that's not what it is. It's P of n is this whole thing. All right, now in a proof by induction, there's three pieces that we want, three specific statements that we're interested in. We're interested in P of 1, P of k, and P of k plus 1. All right, now P of n, or sorry, P of 1, that's like, what would you get if you only put a 1 in there? All right, so the problem with this part for a lot of students is that this is actually poor notation. What they mean is continuing in this way. So, in other words, 1, this is what you get when you plug 1 into 3n minus 2. So 3 times 1 minus 2, that's 1. 4 is what you get when you plug 2 in there. 3 times 2 minus 2. 7 is what you get when you plug in 3 in there. Let's see, 9 minus 2, that's 7. And you just keep doing that. Okay, so P of 1 is just P of 1 is just 3 times 1 minus 2 is equal to 1 times 3 times 1 minus 1 all over 2. That's P of 1. P of k is replacing the n with a k. So that's that. And P of k plus 1, that's, let me give myself a little room here. Let's see, that's 1 plus 4 plus 7 plus all the way up to, let me give myself some more dots here. You'll see why in a second. 3k plus 1 minus 2. And we're saying that that is equal to k plus 1, 3k plus 1 minus 1 all over 2. Now the thing to notice is that okay, now what comes before the k plus first term? Okay, this right here, this is the k plus first term. So what's the thing that comes right before the k plus first term? Is the kth term. What comes before k plus 1 is k plus 1 minus 1. K plus 1 minus 1 is k. So it's the kth term, or 3k minus 2. This is the kth term. Okay, and the thing to notice is that, and this will be really important for the inductive step when we actually prove these things. The thing to notice is that this right here is exactly all of that right there. So if we're assuming P of k, then we can replace what I have in the red box here with that right there. Because we're assuming P of k, we're showing P of k plus 1.